Hey everyone, and welcome. Today, we're going to crack open one of the biggest and most interesting mysteries in all of modern technology. We're going to solve the riddle of the silicon lottery.
I mean, you've been there, right? You're shopping for a new laptop or a new CPU, and you see this just massive price gap. You have to wonder, what's really going on? They look almost identical, they're made of the same stuff, so why on earth does one cost a small fortune and the other, well, doesn't? So on one side, you've got your dependable Core i3. It gets the job done for all your daily stuff. And on the other, you have the beastly Core i9, a chip for serious gaming and heavy-duty professional work. The performance difference is huge, for sure. But here's the crazy part, the part that'll kind of blow your mind. They often start their life on the exact same piece of silicon inside the very same factory. To really get this, we've got to go on a little trip. We're leaving the computer store behind and heading to one of the cleanest, most advanced places on the planet, a semiconductor fabrication plant, or as they call it, a fab. This is where the magic happens, and also where all the problems start. It all kicks off with something that looks like a big, shiny gray sausage. It's called an ingot, and it's a single, nearly flawless crystal of silicon that's 99.9999% pure. This giant crystal is then sliced into these super thin, perfectly polished discs that we call wafers. You can think of these wafers as the perfect, pristine canvases where hundreds of tiny electronic brains are about to be born.
Now, the way they make these things is just mind-boggling. They use a process called photolithography, where they basically use light to etch the chip's incredibly complex design, we're talking billions of microscopic transistors, onto that silicon wafer. They build it up layer by tiny layer, creating this complex 3D city of circuits. The goal, the absolute dream, is to print hundreds of perfectly identical, flawless chips on this one wafer. But you know that word, goal? That's the important one.
Because here's the thing. Even in these impossibly clean rooms, with robots doing all the work and air filtered to an insane degree, perfection just isn't possible. The quest for perfection hits a brick wall called reality.
And that right there, that's the heart of the problem. Chip makers are literally pushing the boundaries of physics, working at a scale so small that the tiniest little hiccup, a single stray dust particle, even a stray atom, can mess up the whole party. What we're talking about are called nanoscopic defects. Now, these aren't like a crack in your windshield, no way. These are tiny, tiny flaws at the atomic level. Maybe one of the microscopic wires for electricity isn't shaped quite right, or a transistor doesn't switch as cleanly as it should. These tiny flaws act like little traffic jams for the flow of electrons, and that directly affects how fast and reliably a chip can do its job. Just to give you a sense of how small we're talking, these defects are often less than 100 nanometers wide. To put that in perspective, that is smaller than a virus. Yeah, smaller than a virus. You can't see them, you can't feel them, but man, their impact is very, very real. So what do, right? You just spent millions of dollars making this wafer. You're not just going to toss it in the trash because of a few invisible flaws. Well, this is where the pure genius of manufacturing kicks in. They came up with a really clever system for sorting them. It's a process called binning.
You know, the easiest way to think about it is like you're baking a huge tray of cookies. You know you can't guarantee every single one is going to be a perfect circle. Some will be perfect, some might be a little crispy on the edges but are still totally delicious, and a few might be broken. You don't throw the whole batch out, you just sort them. That's exactly what happens with computer chips.
So, picture this. Every single little chip that gets cut from that wafer has to go through this super intense audition. They basically strap it into a test rig and push it to its absolute breaking point. They ask it, are all your processing cores working perfectly? How fast can we crank up your speed before you start making mistakes? How much power do you drink, and how hot do you get when you're working hard?
And based on how they perform in this stress test, each chip gets its destiny. The absolute champions, the ones that are perfect in every way, all cores firing, stable at insane speeds, those get the crown. They become the top-of-the-line Core i9s. Then you've got the chips that are almost perfect, but maybe have a tiny flaw in one core. No big deal. They just disable that faulty core with software, and it becomes a perfectly good Core i7 or i5. And the ones with a few more defects that can only run reliably at slower speeds, well, they get sorted into the bin for Core i3s.
Okay, so when you put it all together, this random chance of where defects land and this whole clever sorting process, you get a term that PC builders and tech geeks absolutely love.
It's called the silicon lottery. It's a lottery because the location of those tiny defects on a wafer is totally random.
A manufacturer never knows if they're going to get a wafer full of perfect i9s or a wafer mostly full of i3s. It's all up to chance. This is also why you'll hear overclockers get hyped about finding a golden chip. Maybe it's an i5 that performs almost as well as an i7. They basically won the lottery.
And this is the big takeaway, the thing to really wrap your head around. An i3 isn't a bad chip. It wasn't designed to be slow. In many cases, it was born from the exact same design as the flagship Core i9. It just had the bad luck of being created on a part of the silicon wafer that happened to have a few more of those unavoidable microscopic flaws.
So the next time you pick up your phone or sit down at your computer, just remember that the little processor inside isn't just another mass-produced part. It's a survivor. It's the winner of its own little silicon lottery, a testament to turning random chaos into incredible, reliable performance. Kind of makes you look at that little piece of silicon a bit differently, doesn't it?